Good morning. Today we are going to write and graph exponential decay functions. Before we did growth functions, today we're doing decay functions. So as we jump into it, you're going to realize that your decay factors are going to be less than 1. And that's what makes the graph go down in value. So when we look at our decay factor, it is a fraction. And we're going to go ahead and plot this directly into Desmos. So let's go ahead and type this into Desmos exactly as you see it. Y equals, make sure you put parentheses around your 2/3. And notice the graph. This time it comes down from the left. It comes down from the left and it goes to the right. Okay? So that's what we called an exponential decay function. What I need you to do is we're going to create a table here. So you're going to hit this little settings wheel right here, and then you're going to create a table. So that's all review from 9.1. We did that in 9.1. Remember how we needed to go from -3 to +3 on our homework? It's highlighted at -2. If you hit enter, you can type -2 in there and change that -2, the original -2, to a -3. Maybe, if I can get my phone to do what I need it to do. There. So that way you can see it. Now notice it is a fraction, or it's a decimal, and we need it to be a fraction because all of our answers in pair assessment need to be fractional form in our table. So in order to figure out what that fraction is, you're just going to come down here, 3.375. You're going to type it in box number 3, 3.375, and then you're going to hit this little blue circle here. When you hit that little blue circle, it'll change it over for you. And if you notice, it says 27/8. So that's what we're going to write in here next to -3 in the X box. -3 goes in the X, then -2, -1, 0, 1. Let's expand this box to add 2 and 3. So that way it looks like our homework. So the first one's 27/8. Then it's 2.25. So if I type 2.25 and change that over, that gives me 9/4. -1, 1.5. Hit that little button there, and it changes it over to 3/2. And then 0, 1, 1, and then it's 0.6 repeating. Now, I understand that there's a 7 here, but the only reason that there's a 7 is because it rounded it. So how you figure out that is in box number 3 again. I'm going to start typing 0.6. And notice that there's a fraction button here, but you're going to keep going until that fraction button disappears. Notice it disappeared. Now you're going to keep going until it reappears again. Notice it reappeared again. Now it's recognizing that it's repeating.
My math teachers told me that if it's repeating, then the bottom is always going to be 9, whether it's 9, 9, 9, or 9, 9, 9.
You're correct.
Yes.
Yep. That is absolutely correct. So this would be 6/9, which reduces down to 2/3. But this is how you can do it in Desmos. So 2/3. And what Kinsley was saying is if all of them are repeating, it's over a 9. So this would be 4/9, 4/9. But if you just typed it in, oops, I marked on my phone. If you just type it in, 0.4, if you don't remember that trick, it's 0.4, wait till it disappears, and then it'll reappear again, just like that, and then it'll show you 4/9. And then if we plot number 3, and then if we put 3 in our table, it gives us this fraction, or this decimal, and this decimal is 0.296296, and then there's a 3, and the only reason that there's a 3 is because that 9 rounded that 2 up. So what it's repeating is 296 over and over and over again. So 0.296, 296, 296, and I'm going to keep doing that until that little circle reappears.
Let me guess.
And then it'll give me the fraction. And that fraction is 8/27.
I noticed the negatives and the positives. So like for -1 it's 3/2, but 1 is 2/3. So I figured if -3 is 27/8, then it's going to be 8/27.
Yeah, and actually that does happen. It doesn't always happen that way, but in this problem it does.
Like figures.
All right, so let's go ahead and graph it. Go ahead and graph it. And you don't know how to graph fractions, and I understand that. So let's look back at the decimals. It was -3 and 3.375, so a little bit past 3. So -3, 1, 2, 3, and then 3.75. So roughly there. -2, and then a little bit past 2. -1 and 1.5. Then 0, 1. What is that point called right there? Does anybody remember? The y-intercept. Very good. And then 1 and 2/3, we're starting to get below that 1. 1 and 4/9. It's getting really close to that x-axis now. 1 and 8/27. And then as I connect the dots, it never crosses that x-axis. And this side is going to circle and kind of go up like that. So you just graphed your very first exponential decay function. So let's look at number 2. Go ahead and expand your table down 2 more. We're going to go from -3, -2, -1, 0, 1, 2, and 3. Go ahead and type that in exactly as you see it. Y equals 2 times parenthesis 1/3 raised to the x and this is what it looks like. We need to get the numbers in the table. So you're going to hit this little settings wheel, and then you're going to create the table. So at -2, it's 18. -1 is 6. 0 is 2. That's what I can see so far. I'm going to go ahead and click enter and make that a -2 and this one a -3. -3 is 54. Now, 1 is 0.6 repeating, which we just figured out was 2/3. 0.2 repeating is 2/9 because of what Kinsley just taught us. And then if we hit 3, it's this number right here, 0.07407,407. So what's repeating? So 0.074074074074074. Is it gonna come up?
That's something like you're telling me. Hold on, that's something like you're telling me 10 times online.
4074.
Do you remember how to do it?
I think I typed something wrong. Hold on. 074. What'd you guys get? 2 over 27? I'm struggling trying to type it in. It is 2 over 27. I know that.
That's not making a bit funky right now.
No, my finger's being a bit funky. I can't type it in.
Oh.
All right, let's go ahead and graph it. So as you graph it, it should look like this, where it's coming in right here, and then it swings down and it gets really close to that x-axis. Okay? So can you graph -354 on this little graph? No. Can you graph -218? It only goes up to 10. How about -1/6? Yes. So -1 up 6. 1, 2, 3, 4, 5, 6. 0, 2. What is 0, 2 called? The y-intercept. 1 is 2/3, then 2/9, then 2/27. And don't forget arrows on both sides.